Let's take a minute and review describing variables and making combinations just to make sure that we don't miss any. So the first step whenever you're describing variables is to identify each variable on its own and to give the appropriate description of that variable. And the appropriate description is going to entirely depend on how it was measured. If it was measured categorically or continuously. If it was measured categorically, you're going to count how many were in each of those levels, each of those groups, and you're going to present the frequencies and the percentages. If it was measured continuously, you think for variables that were measured continuously, if you think that they're normally distributed, you're going to report the mean and the standard deviation. If you think they're skewed, you're going to report the median and the interquartile range. Another question to consider at this point, where you're just describing and identifying each variable on its own, is to ask if it's clearly an outcome or clearly a predictor. Some variables can be both. Some are clearly only predictors, some are clearly only outcomes. For example, a fixed characteristic like gender or ethnicity is unlikely to be an outcome variable in social science research. So it's likely to only be a predictor. And in experimental research where you have manipulated something, that is going to be a predictor variable and it isn't going to be an outcome variable. The second step is to consider relationships with one predictor. So you match each possible predictor with each possible outcome and just are looking at combinations of two variables. So if we've got three variables here, variable A, variable B, and variable C, here are the possible combinations we would want to look at. We would want to ask ourselves, is variable A related to variable B? Is variable A related to variable C? And then the last possible comparison we can make is variable B related to variable C. And so here's how we would maybe summarize that: A to B, A to C, B to C. We want to just check that we're making all of the appropriate comparisons. Listing all of the possible comparisons is a great first step, but then to really critique and query, does this make sense? Is this sensible to compare this relationship? The third step is you then look at relationships with two predictors. So in this case, again, if we've got three variables, variable A, B, and C, we'd be looking at variable A and B and C, and that would be the only possible relationship with two predictors that we could make. Things get pretty complicated as we start adding variables. So if we add one more variable, we've got variable A, B, C, and D. So here's the first step, relationships with one predictor. So we would look at is A related to B? Is A related to C? Is A related to D? We then start with variable B and we ask, is B related to C? Is B related to D? We then move down to variable C and ask, is C related to D? And this is the list of all of the possible two variable pairs, the comparisons that we could make with two variables, one predictor, one outcome. Next, relationships with two predictors with those four variables. So we're looking for combinations where two variables would predict one outcome. So we're looking for combinations of three variables in all. So we could say, do variable A and B predict C? Do variable A and B predict D? Do variable A and C predict D? And then we'd move on to variable B. Does B and C predict D? And that would be the ones that we would be able to make, the combinations of three variables, and there they are listed. So how many combinations will there be? How do you know that you've got all the combinations? With two variables, there will be up to three comparisons. So there would be the two single variable descriptions, and then the one two variable relationship. So if you've just got A and B, you'd describe A, you'd describe B, and then you'd see if A and B were related to each other. Three comparisons in total. With three variables, there will be up to 7 comparisons. You'll have the three single variable descriptions, and then the two variable relationships, A, B, A, C, B, C. It looks like there'll be 3 of those, and then a single 3 variable relationship. With 4 variables, there'll be up to 15 comparisons. The 4 single variable descriptions, and then the 2 variables A, B, A, C, A, D, 6 of those, 4 of the 3 variable comparisons. And then that final 1 4 variable relationship. So is there a pattern to those numbers? Is there a pattern to the 3, 7, 15? Sure there is. 2 variables is 3 comparisons, 3 variables 7 comparisons, 4 variables 15 comparisons. If you want to calculate how many comparisons there are, you can use this formula. You take 2 and you raise it to the nth power, where n is the number of variables, and then you subtract 1. Let's also just review and add to how we decide how we're going to relate relationships with one predictor variable, how we're going to evaluate those. When we have a categorical outcome by a predictor, a categorical predictor, we've described that with percentages, and we've related it using that chi-square inferential statistic. When we have a continuous outcome and a categorical predictor, so we've got groups in the predictor and a continuous outcome, we have calculated the means and standard deviations for those different groups, and we've completed a means comparison. Now this one is new when we've got a continuous outcome and a continuous predictor. We will describe it with an XY scatter plot, and we'll relate it with a correlation coefficient, and that's abbreviated by R. And finally, when we've got relationships with 2 predictor variables, so we've got an outcome by predictor and predictor, here are the 3 patterns that we are likely to see with that. One of those predictor variables is always going to be categorical. And so then the question is how many of the other variables are also categorical. So if they're all categorical, you've just calculated multiple chi-squares. If you've got 2 categorical predictor variables and a continuous outcome, you've got groups by one variable and groups by another variable, and you've calculated means and standard deviations for each of those groups, and you're going to compute multiple means comparisons. And you end up calculating an ANOVA for that. If one of your predictor variables is categorical and then the other predictor is continuous and the outcome is continuous, then you're going to have multiple groups of continuous predictor, continuous outcome. So you'll have multiple XY scatter plots and multiple correlation coefficients. Let's go see what those look like.